So that's why the first point to understand is that there is, the world is not objective. We cannot put the whole world into an equation and say, okay, happiness means this is the equation. That okay, no. So therefore, we see that because the world doesn't exist in a state of objectiveness or in an objective state, therefore, no amount of objective, objective gathering can lead to. So therefore, so no amount of objective items, a gathering of objective items can lead to a state of meaning, fulfillment, happiness. We can see this. People are driving behind material objects, say bank balance, opulences, luxuries, comforts, name, fame. So they want to gather all these things objectively. Okay, my bank balance is this much. I have a property worth this much. My car is this much. I have these many luxury items in my. I have this much fan following. This is my social media fan following. So this drive for quantification, although everybody is chasing after it, but then the one subjective observation which we can see is that whether one is a winner, whether one is a loser, everyone is dissatisfied and empty in his life. So this goes to show that the world is not in an objective state. There is subjectivity. The subjectivity comes from the state of our consciousness. The subjectivity is coming from the state of our consciousness. What is our heart? How is our heart? The state of our heart determines how do we perceive things. So there is subjectivity. There is subjectivity. I have seen sometimes you give a same seminar to one class of audience or to the same type of audience in 1 year, they appreciate a lot. The next year, the same kind of audience, they don't appreciate. They say, okay, whatever is okay. It's not much, not much substance in it. I have seen sometimes, if you explain by giving different real life examples to people, then they get convinced, they feel happy. Okay, you give examples from doctors, engineers, lawyers, businessmen. Another person will say, "Arey, itna example de raha hai." This is subjectivity. What is our internal state matters the most. And when we talk about subjectivity, we are talking about perception. How do we perceive the things? So that means reality is different from perception of reality. If we have an improper perception of reality, then our experience is going to be much different. So quantum mechanics gives an interesting purview to reality. So many scientists talk about that, yes, quantum mechanics is, so the entire formulation of quantum mechanics, the science of quantum mechanics, or the theory of quantum mechanics, is about an explanation or an observance of something mystical which is happening in the subatomic world. Something magical and mystical, inexplicable which is happening in this subatomic world. But then scientists and Nobel laureates acknowledge that we know that the subatomic particles behave in a very mystical and a mysterious way. We know that they behave in a mysterious way, but we don't know why they behave so. So in fact, one of the Nobel laureates in quantum electrodynamics, Richard Feynman. He made an interesting observation. He said that if you think that you know what is quantum mechanics, then you don't know it at all. That is quantum mechanics. And then he says, okay, this is the world of quantum mechanics. So therefore, Max Born says that yes, the theory is more intelligent than us. It knows why it works. So we are not able to tell why it is working, but we are only able to tell that there is mysticism which is existing. There is, it is enigmatic, it is mystical. These small subatomic particles behave in a mystical way, which we can only observe, and we can clap seeing that. And what the modern day quantum science research is doing is that, and we can just clap and tap. So they understand that this phenomena happens. Nobody understands why it happens, but because they know it happens, we have made a gadget out of it, and we are utilizing it in an industry perspective. So we only know how to clap and tap. Yeah, Max Planck, 1935. Yes. So quantum mechanics, the physics has gone beyond the grasp of its creators. So what is this mystery all about? Before we go into an understanding of the mystery of these, how these small quantum particles behave, before we go into their mystical, amazing behavior, and then try to understand and draw lessons from that, let's talk about let's talk a little bit about the paradigms. How do you approach a problem? So now, given a problem, we can approach a problem through common sense. Science approaches the problem in a particular way, in a particular methodology. That methodology is called as scientific realism. Scientific realism. So first of all, observation, in what way the observation is perceived, is very important to our experience. So now, like say for example in this slide, what you are seeing here is a table. It's a brown table. Now if somebody asks you a question, okay, what is this? What is the reality? So okay, reality is a brown table. So now this is common sense. It's a table, brown table. You can do your work on the table, you can work on a laptop, you put your head down, go to sleep on the table. It's a table. Now how does a scientific reality perceive it? Science says, no, it's not just a table. So scientific realism is a particular kind of methodology of looking at reality. So if you follow the scientific way of looking at things, then you will say, okay, it's not a table, it's a set of atoms which are vibrating about their mean positions. It's a set of atoms. They are following a constrained vibrational behavior. It is not non-constrained. You can put equations of constraint. It's a constrained behavior. That's reality. That's what it is. So now, in one sense, we may say that yes, when we approach something scientifically, that we have broken down a thing. So we have broken down a thing into its small constituents. It's such a big table. We have broken it down into atoms. We are talking about a big object in terms of its atomic. So we have dissected it. This is called as a reductionist approach. But now, what is the experience at the face value of this approach? That's what we want to talk about. So now, okay, it's a table. We may say, okay, you can say it's a brown table. You can say it's atom vibrating, like that. But suppose now let us take another example. Say for example, gulab jamun. So it doesn't require a PhD degree to be able to explain what a gulab jamun is. A 3-year-old child can also explain. If you say gulab jamun, he may say, okay, very nice, I want it. Gulab jamun is something what I want. It is something which is very nice, very relishable. So, now if you apply scientific realism, that okay, from a scientific perspective, what is the reality of the gulab jamun? Then those roadways will take you to understand that okay, gulab jamun means there are some 100 micron globules. These 100 micron globules are coalesced clusters, and these coalesced clusters are suspended in a highly viscous fluid, and these globules are showing different shades of color patterns, from brown to white. And you can give values of viscosity, and you can give values of the diameter, the average diameter of these coalesced globules, or the aggregates of these globules and all that. Now, the question is, how much does the explanation, and we may think that okay, we have done an ingenious job, and one can publish a paper on it. These 100 micron globules, which are suspended in a colloidal state, and how they relate with the viscosity, and how they relate with each other, and so on and so on and so forth. And we can give a full mathematical analysis, but that mathematical analysis misses out on a very important detail, and that very important detail is that this description doesn't tell anything about the experience of a gulab jamun. The essence of the gulab jamun is its taste. And in this case, this approach of mathematically formulating it has completely spoiled this the essence of the gulab jamun. In fact, if you hear the explanation of the gulab jamun in terms of size and viscosity and fluid dynamics and the surface the surface forces and the surface tension and the van der Waals forces, the forces for action, the forces of repulsion, Brownian motion. I mean, it's going to give a very dreary view of what is a gulab jamun. So you don't need a mathematical formulation for it. We don't need a dissection of it. When we are dissecting, we are actually missing out on its essence. And what we remain with is something which is very dreary. All we need is, all what we need is to eat 2-3 of them. That's what we need when it comes to gulab jamun. So this goes to show that many times it is, it's not, when we say something as reality is a very subjective concept. And if we simply apply a certain tool to understand reality, we have to understand that that tool is not absolute. And therefore that tool or formation may miss out a very integral part of what is reality, and therefore may give us a completely different picture that way. So now may give us a completely different picture. So this goes to show that the modern day scientific approach of reductionism, reducing everything into its so small constituent parts, completely misses on a very important dimension. The experience is gone. Where is the experience in that? Is it not? Just like we may say nature. Now, so many people, they have a habit of, so many people feel so much excited about interfacing nature, the greenery, the mountains, the iconic beaches. Now one may say, when we want to capture it in the camera, we want to capture it in in social media profiles, when we want to capture it, and it's hard. But we are not interfacing reality in terms of an atomic scale. What are the atoms and molecules and how they relate with each other? Imagine. Just imagine that suppose if we had some microscopic vision, how will the world appear to us to be? Very ghastly, very horrible, is it? So that means, the scale is very important, right? So just imagine, if our eyes had a microscopic vision or a telescopic vision, say for example, the world would be very ghastly for us. But because it is an optimum scale, there is a certain amount of zooming, there is a certain amount of positioning which is there. Therefore, we are able to relate the beauty of this world in a particular pattern. So now, the question is that okay, at whatever scale of positioning and zooming our eyes are on, the question is to think about, to ponder over is that, and is this world beautiful? The beauty what we see in this world, is it there or not there? Because if you change the zooming, if you change the positioning, then it doesn't appear to be the same, is it not? If you zoom in to a microscopic level, then the beautiful object is no more beautiful. It's something different now. So therefore, we can understand that yes, many times simply reducing things, a reductionist approach will not work out. A better alternative is to have a holistic approach. To have a holistic approach towards the understanding of everything. So in that sense, we can understand that science completely plays around in effects. But again, effect is not the full approach because it is not holistic. Because effect doesn't exist without a cause. And unless you understand the cause, you cannot, unless you understand the cause, then the, to work out with the effect is not a problem. It's not going to work out, is it? So that's why we need a deeper vision. We need a more holistic vision. We need a vision which is inside out, which is outside in, inside out, outside in, like that. This is exactly what the Vedic Shastras are giving us. When they explain that the Lord is within, the Lord is without, the state of the heart very much correlates with the state of the world. This is what it means, that we are trying to interface now reality in a very holistic perspective.